Quantum computing is everywhere right now, but what actually works and what's still just hype? Today, we're joined by Abhigyan Mishra to talk about real-world quantum advantage, finance, and building quantum-ready software today.
Hello and welcome back to Impact Quantum, with a podcast we explore the emerging industry of quantum computing, quantum sensing, quantum biology, all that good stuff that's out there. And you don't need to be a PhD. You just have to be curious. And with me is the most quantum curious person I know, Candace Gooley. How's it going, Candace?
It's great, Frank. Thank you so much. I'm so happy. I know it's silly, but the weather's actually warmed up. So it's like just hovering at freezing. So it's like time to go outside in shorts. I'm very excited.
Yeah, that's like summer. That's almost summer weather in Montreal.
I'm telling you, downright balmy for Montreal, Quebec.
So
today,
Candace, we're getting above freezing today for the first time in like 3 days, which
oh my God,
it's a big deal for us. Yeah.
Well, hopefully it doesn't refreeze then, and then all turned
to ice. Oh,
it
totally will. So
there you go. Okay, so today we're lucky. We have Abhi Mishra, and he is the quantum director and co-founder of Rune Technology. Hi, Abhi. How are you doing today?
Yeah, hey Candice, pleasure to be here, and looking forward to a good conversation.
Awesome.
Excellent.
So, what can you tell us about Rune Technology?
Rune Technology itself, without going too much in detail, because it's a financial related company, so I cannot reveal too much because that's where our bread and butter lies. But what we do differently is we look at the market with a different perspective. We are a quantum enhanced AI based company. Obviously we provide signals and everything. And what we do differently is obviously we enhance the already existing AI models with a representation given by a quantum based approach. So that's, to sum it up in a very few lines, that's what Rune Technology does.
Oh, very cool. Very cool. You mentioned signals. I assume you're meaning kind of what other people would call market intelligence, being able to read the market and kind of pick up on things before other people do. Is that roughly kind of what you do? And we lost his camera.
I can see that, and I have no idea why that happened. Just give me a second.
Oh, that's okay.
Yeah, I should be back now, right?
Yep.
Yeah, so I was saying, you're exactly right and on point with that. Signals is basically exactly, you can say the information on which other people acts and trade. So yeah, that's exactly, you're on point with that. And what we do differently is, we don't, just limit ourselves to one particular market, right? You can have information from different sector, different market. And obviously, at that point, the problem becomes about scale, and when you think of scale, that's where, the AI and the whole compute cost and everything comes into picture. And I'll say that's something interesting is where, how we, put quantum in this whole aspect of it. And when we say quantum enhanced, where exactly does quantum come in? To put it very simply, we sort of compress the market data in a way that, the AI models can better understand. The AI is itself a different game, that's a different architecture. It's also very sophisticated in itself. But obviously the data in itself and the purity of data, that's where I'll say the quantum part comes in.
Interesting.
So your solution is AI and quantum together. Is that what you're saying?
It's a quantum enhanced AI, I'll say. That's
Okay.
the precise way to put it. Yep.
So how would you explain to a non-technical person what it is that you're doing?
See, to a non-technical person, in general, what do you mean in reference to Rune Technology, or in general, what do I do?
In general, what are you doing? What is Rune trying to do? What problem do you want to solve?
In general, I'll say that, my expertise particularly lies in, bringing technology like quantum computing, which probably and everyone thinks is a very niche tech, right? Into something so basic and so rudimentary, at the same time so complicated, like financial market. And what I do is I try to figure out where in the pipeline, the classical pipeline, where the bottleneck lies, the right point, the right spot to even think about, anything quantum related. So that's where my expertise lies. That's what I do. And in reference to in this root technology, as I suggested, as obviously, I cannot deep dive into it, but as I suggested, the complex, the you can say the alpha or the elegance really lies in the fact that we represent market in a different way, which allows us to kind of collaborate or compress more data, so that the AI architecture can better understand it and give the results, whatever these are signals, whatever we generate.
Interesting. How widespread is quantum in finance now? Is it still kind of, it's definitely still cutting edge, but I mean, is it kind of fringe? Is it kind of almost mainstream? Is it, we all know the big stories, HSBC, JP Morgan, but like, I know banking has a rigid hierarchy of like, who's the top dog and things like that. But all, like obviously if the top dogs are looking at it, right, I don't want to name banks because they're going to get upset that you didn't rank them among the top dogs. But obviously the top global banks, they're looking at it very clearly. They're seeing some initial success. But what about kind of like somewhere bigger than regional? Like what's their take on this?
I think that's a very interesting question. And I'll say, I'll take an example of AI in this particular case, because AI has always been a thing of interest in the financial market, in financial sector as well. But
right.
The issue with this particular industry in general is
right.
They jump into this before they truly understand the the scale and the understanding of what the sector really brings in. And I can say the same for AI, right? You can probably find the AI research team in every other hedge fund or every other financial, not even talking about banks, in general, in every other major financial firm. But how well are they implementing into the practical pipeline is something kind of, iffy, I'll say. And there's a very strong reason about it. And I'll say, like I said, because before diving into the financial sector, I do have some around 4 or 5 years of experience in automotive sector and aerospace sector. And I'll say there's some similarity which lies from that sector to this sector, which is exactly the resilience to a change, right? And how hard is it to penetrate these kind of these kind of sectors. So as you said, there's a hierarchy involved in this, and the people they are pretty I would say comfortable with the legacy methodologies which have already worked, and they're comfortable because they understand that, right? So yes, technologies like quantum computing, artificial intelligence are making their impact in the financial sector. But I'll say there's still, I think now it's a more prominent, but there's the wave of actual acceptance and adoption of the technology have started in a very, very recent, I will say, past. So the same goes for quantum computing. To answer your question in short, right? That yes, major firms do have quantum computing as one of their team, but it's mostly R&D, right? And when it comes to practical application, yes, there are a lot of limitations of how you implement that tech, but I feel like the approach there is kind of diluted, and I cannot blame the R&D team for that. It's about how much acceptance you get from the higher ups as well, before you actually try to implement anything into the practical world. Yeah.
So, given the highly regulated nature of banks around the world, and I know this has been a factor with AI, right? Like you have to have some kind of explainability.
Yep.
What's the current state of regulation around quantum in finance, right? Is it still too new? Because, I live in the DC area, right? And there's a joke that, technology is not real and actionable until the government decides to start regulating it. Where do we stand? Where does particularly in finance, I think finance is usually one of the first regulated fields. Like, so is it pretty much no regulations yet? Somewhere in the middle?
I'll say yes. And this is pretty much very new. And
right.
As I said, that the adoption is still very low. And you don't see that many legal aspects and ethics come into the picture until the adoption
Right.
becomes to a point where I think to a point where we are not talking about it as a niche technology, but we're talking about it as a necessity. Like I
Right.
mean, if you think, always always go back to AI. When you talk about quantum, because I feel AI was exactly where quantum is right now, around a decade ago. And if you look at it right now, if you think what's the major reason why ethics became a subject, when you study AI, is obviously because of the adoption of AI in mainstream technology. When you start to think about it, if every other man has access to such a cutting edge AI technologies, then you also have to consider ethics. So I will say that right now, if as long as the adoption rate does not cross a certain threshold, ethics wouldn't be a thing. And as you said, the jokes and your stereotypes are more or less based on real facts. So as long as the adoption doesn't reach a particular threshold, yeah, you're not going to see any kind of ethics involved with quantum compute. There are ethics on cryptography, yes, but
Right.
that I feel is kind of like on a different paradigm and not on quantum computing and the computation based problems.
Well, that's fair.
Yeah.
Sorry, Candace, I don't want to monopolize the mic.
So many financial problems are already well served by classical HPC. What specific characteristics make a finance problem genuinely quantum advantaged?
Well, that's a very interesting question, and I think that's where most of the research lies. And as I said, yeah, especially in my case, that's something where I feel like I spend the most time on. Well, to be frank, to be honest, and there's this financial sector is the newest sector which I've dived into. So I have less than a year experience in this. As I said before this, I was in automotive and aerospace industry. So, but although I will, answer your question in reference to that because I feel they share a lot of correlations. It's a different, it's the same thing, packaged as a different stuff. And what I mean by that is, see, both of these problems basically suffer from high volume of data and high velocity of data. In overall, you have a huge data coming in, every second. So the problems are, I'll say not same, but same thing, but in a different paradigm. So to answer your question, yes, there are algorithms out there, HPC algorithms, approximation algorithms. So I do have a PhD in computer science, so I understand that there are these algorithms. But the thing is that these algorithms at their very core, at some point of time, have to take an approximation if it crosses a certain threshold, right? Like for example, if you think about it, the very simple case I can tell you is that if I ask you to map the dynamics of a multi-particle system, if you have multiple particles in the system, even in physics, which is like one of the purest form of science, you have to take an approximation if you want to solve the problem of a particle in a box problem. And when you do so, you lose information. I think that's where the quantum really helps in. So obviously, I never say, and I'll repeat it again, quantum is not one solution to all problems. It is the job of people like me and other experts like me to identify in a pipeline where exactly does the quantum really come in and help to unclog, let's say, a bottleneck which was really overall reducing the performance. But to say that quantum is going to rebuild the whole thing, that's insane. Quantum is not that kind of computing. It's just another way of looking at a problem. But yes, you have to identify a problem where you think there does lie an expertise. Like one of the most common one in financial market is portfolio optimization. And the reason, and there's a very good reason why that is so relevant, because if you think about it, what is portfolio optimization but not a multi-particle system? You have one asset, two asset, 10 different assets. You need to find a perfect a path from point, perfect path, or I will say a perfect graph out of this whole network, which can give you the maximum profit. There are HPC algorithms for it. Yes, true. But if you represent this problem as a quantum computing problem, you get better results. It's as simple as that. You get better scalability. So it's as simple as that. I don't want to complicate it any further. It's as simple as looking at a problem, identifying where this bottleneck lies, and if quantum can solve it. Because not every bottleneck is going to be solved by quantum computing. There is only specific problems, but those problems might lie in one of the, you can say the core pipeline of the whole thing, of the whole industry. That's it.
That's a fair way to put it. That's a fair way to put it, right? Like, quantum is not going to solve. I think that's one of the biggest misconceptions. Is, it's going to solve everything. Well, not everything, right? Again, who knows what the future will bring, like 50 years out? Because I doubt that the people working on transistors at Bell Labs in the 40s and 50s were thinking about TikTok, right? Right. I suppose. I mean, who's to say? But I think in the near term, probably a decade or so, I think it's safe to say, like, it is a very finite problem set that quantum can work on.
Yes.
That having been said, beyond that, who knows? Sorry.
No. How do you think we can make advanced topics like quantum computing more accessible to broader audiences without diluting the complexity?
Again, that's a good question, and personally, I have tried to do that. Actually, it's funny because I started my quantum journey. The first venture, which I went ahead with was my own venture, and it exactly targeted this. And because I myself do not come from a quantum physics background, I come from a pure computer science, theoretical computer science kind of a background with a master's and PhD in the same. So I felt the same, that, it could be very daunting, the maths itself, and and obviously, when you study about algorithms and pure quantum algorithms, it does get very daunting. The maths, they do say it's just linear algebra. They never tell you how complicated it gets so soon. You don't even get time to, wrap your mind around it. But at the same time, I also felt that, it's an intuition which, we can really get out of these things, because yes, yes, you need to understand quantum physics to get a complete understanding of quantum computing. But at the same time, do you really need to understand everything from top to bottom to know if it even makes sense in your business? Obviously, you would need a guy like with a PhD in quantum physics to make the hardware for it. There are going to be guys like that. You would obviously need someone with a PhD in quantum physics to really write the maths for the algorithms. Yes, but you also need someone who can understand the intuition, because, like, see, in my case, I cannot understand financial market from A to Z. That's true. But I need to know it enough, and I need to know my stuff enough to form a bridge between the two. So to answer your question, how do you make so complicated topics simple? You explain the intuition. You make them understand what really is happening from an intuitive point of view, at least. I mean, that's how I feel, at least, anyone from, who is looking to get into this sector should have an understanding of an intuition. If they like it, and if they want to delve into it, obviously deep dive into the maths, get a better understanding. The more you go in, the better you feel, the better you get a grasp of things. But start with intuition. That's how you slowly get your way to the end.
Okay.
Very cool.
Where do you see the most promising near-term real-world impact of quantum technologies across industries like finance and optimization or cryptography?
Obviously, cryptography and optimization is always, the lowest hanging fruits, because these are two sectors where, you can actually use the scale, because that's where the scale of the problem for optimization, the scale of the problem becomes a complexity. And for cryptography, it's a completely different regime there. The encryption and decryption, all those cryptographic algorithms, they come to the picture. But these two fundamentally, if you think about it, are very mathematical problems, right? And within those maths lies, I can argue, not, I mean, you can't quote me on that, but I can argue it's just linear algebra at its very core, both of these problems. So there are, I'll say, very low hanging fruits in both of these sectors. And whenever a real quantum, I'll say not real, but a fault tolerant, full-fledged quantum system with enough qubits to solve these problems, I think these would be the first two sectors which will be obviously influenced and targeted from both a financial point of view and, I'll say, in general point of view as well. And after these two, if I want to say, well, Yeah, no, I think that, I mean, I'll say within optimization, there's a lot of things which could be done, because within optimization, I'll say the machine learning also comes into the picture. Quantum machine learning, QML, that also I think will fall under optimization. So yeah, I think these two sector particularly.
Very cool.
What advice would you give someone trying to break into quantum engineering as a career today?
I'll say again, same thing which I said before, that start with building an intuition. As a book, I really liked Quantum Computing for Computer Scientists. I mean, I have a bias because I am a computer scientist, so I have a bias towards that. But I'll say now there are a lot of lectures out there, so go through those lectures. And yeah, one important thing is I'll strongly suggest to participate in hackathons, these quantum hackathons, and I do so because that's how you get to understand how are people thinking about a problem and how are they mapping the problem to an algorithm. Because you can study all the algorithms you want. You can study Shor's algorithm, you can study Simon's algorithm, Dijistra's algorithm, but where do they map into a real world problem? Obviously, they're simple, obvious answers. But when you meet people in hack, because that's how I started my journey, and that's one of my personal advice to anyone who's starting their journey, is you start to see the insight and the thought process which people have when they think of a problem and how they map it to a solution. Solution being the limited set of algorithms which we have, or whether it makes sense to go towards this or not. I think once you start to build that intuition of how to map any classical problem into a plausible quantum problem, that's where I think the real edge lies. I'll say it's the hardest thing also, but that's something you should start building from day one, because the maths and the quantum physics part, it will take time. It will take time. You'll have to go through a lot of lecture. You'll have to watch the Feynman's, lectures from Mr. Feynman, and you'll have to go through a lot of lectures to get to that point of time. But at the same time, I think this is important to kind of build an intuition in your journey. Yeah.
What first drew you into quantum computing, and how did your early experiences shape your approach to both research and advocacy?
I don't have. I'll say I have a very anticlimactic answer to that. Before quantum computing, I was actually working on blockchain, and before that, I was working on IoT. Okay, so and I started with quantum back when the COVID started. I mean, blockchain at back then was starting to get some hype, but I was looking for something new, and I saw this video on YouTube. It was from Microsoft. It's an old video. I think right now it would be around 6 or 7 years old. So it was from Microsoft. It was a like introduction to quantum computing from a computer scientist perspective or something. I watched the video. I liked it. And around same time, IBM was conducting, I think it's second quantum hackathon or something. So I got to know about it. I participated, obviously. And yeah, and rest is history. And what happened was that, to be very honest, what happened was that this happened around the time when I was about done with my bachelor's. So I was already looking for something solid. Like, okay, now I have to make a career. It's fine. I've been doing all this cool stuff like IoT and blockchain. Now I have to pick something. I have to make a career out of something. I would say it was pure luck that I just stumbled upon quantum computing and just picked it up. And to answer your question about how the initial journey was, I'll say at least from India, we didn't have many people. Like other than me, there were like 3-4 more people, who were really interested and were part of this hackathon and everything. So yeah, there was a lack of community initially. I agree. But at the same time, how things have went, from that to, where things are right now, I feel any kind of difficulty which I had with, finding resources online, because all of the books were mostly quantum mechanics book. It was for quantum physics people, not for someone from, like there were 1 or 2 books, which I, as a computer scientist, could study and, grasp some intuition, but mostly it was for physics people. But now I think, you can just go on YouTube and just type quantum computing and just type the word intuition or lectures, and you'll get thousands of results. So yeah, things are much better now, and I like the fact that it's that because now in India also, we have a huge community of enthusiasts from I get every day I get at least one or two messages on LinkedIn asking that we want to get into this sector, how do we do this and that. So yeah, from then to the now, obviously things have escalated a lot. It has really gained a lot of hype, and that's why I always say that quantum right now is what AI was around 10 years ago. People were interested, they wanted to get in, they didn't know understand exactly what was happening, but yeah, it still hadn't got that that adoption thing, but it was getting some hype because hardware was coming in, right? So yeah, I think we are at the same thing with the quantum right now.
I think that's fair. I think that's a fair way to put it. Interesting. Where do you think we're going to go? Like, what do you think 2026 is going to have in store for quantum? I know that's a really tough thing, but I think if I had to sum up 2025, Candace can confirm or deny, was kind of, wow, this is going to be a thing. This is going to be an industry. Where do you think we go from here? Like, what, imagine a year from now we're talking and we're like, well, how could you put 2026 in a word, in a sentence? Is it going to be kind of like, wow, that was a year, or is it going to be like, oh man, that was a year? How do you think it'll go? I know it's hard to predict the future.
That's I think that would be the hardest question you can probably ask me.
Right.
To answer that, I personally feel it's just gonna be a year. I think yes.
Yeah.
Okay, yeah, it's just gonna be a year. I don't think something very major happening right now, and I'll tell you why. Because 2025 was a banger, and banger in the sense that a lot of big names, big companies, kind of revealed a good sense of their timeline, I'll say. So
Right.
if you're talking from a hardware development, that's what I feel would be just like saying that Nvidia tomorrow comes up with a new architecture. It's like saying that. So I don't think that's going to be something which really happens. On the other hand, on the software side of things, well, I think it is going to be very, very interesting. And I say that because I mean, if we had like 100 startups in last year, we're going to have 100 more. I'll say 200 more this year. Quantum is getting edge. So software side is always got every year of our quantum software is going to be something new, something interesting. Because yeah, that's the last thing to close it up. It's always the more people you have interested in something, the more possibilities you have, and I think that's going to really pay off now. That's it.
Interesting.
You've participated in beginner-focused discussions and podcasts about quantum roadmaps. What's one piece of advice that you consistently give to beginners?
I think again, for beginners, it's always to build an intuition first, because and not to be scared from the maths, right? And if you can kind of focus and map whatever you learn, in your journey to real world applications, is that you're on the right path. Even if you don't understand the maths, don't be scared. It's something which takes time. The maths takes time to understand. It's I mean, as they say, if you understand quantum mechanics, you don't understand it. That's how they put it. So you don't need to understand it from day one, but you do need to understand what it means and how you apply it to any problem. So yeah, just focus on that as a beginner. That's all you can do. And to expect something more out of you is, it's kind of putting yourself under the kind of pressure which you can't get out of.
Oh, cool.
How should policymakers and educators collaborate to build a quantum-ready workforce and lessen the gap between hype and expertise?
I think that's one of the I think one of the most future-looking question, I'll say. Yes, I agree this should be the case. It obviously makes sense to integrate such a promising technology like quantum computing into the coursework. And I don't mean it in a way that, they should understand everything about it. But I mean, the other day, one of my cousin, she's in 10th standard right now, and she's studying about AI, right? And ethics in AI, by the way, which baffled me because I was like, uh, back then, AI was something I wasn't even aware of. AI was supposed to be a subject which we studied when you reached in your bachelor's final year and in your master's. We had no idea what AI was, and even then, AI was just about deep neural networks, RNNs, and all of these things, just the mathematical stuff and these things. So similarly, I feel like quantum technology can be part of one of those things, one of those curriculum where they understand what this technology is about. At least they can know what a qubit and what a bit is. Like they can understand what kind of advantage these technology is, I mean, thought to have, right? So just a bit like, they can have a basic understanding of what cryptography means, what quantum sensing means, what quantum computing means. At least they should know and be able to differentiate between the three. And so that I think it's pretty rudimentary, but at the same time, it gives them an understanding because later in life, right? Let's say they do build an interest in this and they go on to pursue a full-time career in quantum computing. Good for them. But even if they don't, let's say they do become some big executive, right? Or they join the mid-level executive, they should understand quantum computing enough to be able to know whether it's a good fit for the problem which we are having or not. Because that, I think, is the biggest gap in the market right now, the mid-level executive. Because I know quantum is a buzzword, and you can kind of pitch any problem and say, we'll just improve it using quantum. But yeah, I think we need more people at executive level who doesn't need to know the whole technology, but just have an enough understanding to know, okay, this is bullshit. So yeah, I think that's why I feel
No, I mean, it's a
it's
fair way to
important
put
to.
it. That's a fair
Absolutely.
way to put it, right? And that's kind of the basic premise of the show since we rebooted it last season was it was based on something somebody had told us that there's enough PhDs in this field already. We don't need more. It's basically kind of what he said. And I'm not discouraging anyone who has a PhD or wants to pursue a PhD in this because, go for it because, you all are going to be the core of the engine. But even if you think of, you extend the engine metaphor even further, right? To build a car, you need not just the engine, you need the transmission, you need the wheels, you need the windshield, you need, the car seats, the airbags, it's very cold here, as we were talking about. Like you need the seat heaters, right? As well as a new feature I discovered, a heated steering wheel, which is completely new to me. It sounds like a complete waste of time until it gets really cold.
Yeah, you live in Montreal
Yeah.
and it's a must-have. It's a must-have. I'm telling you, after you scrape that ice off your windshield, your hands are cold. So,
Or you have
heat.
to shovel or whatever, and you're like, you get in the car, you're like, oh yeah. Sorry, that's a bit of a sidetrack.
So, what's a quantum concept that you initially misunderstood yourself? And how did that aha moment change how you explain it to others now?
Hmm, that's a question I'll take a minute to think about it. Hmm. Because the reason I do so is because I have misunderstood a lot of concepts, and I mean it when I say that as I went ahead, I understood more and more. I'll say entropy is
Oh,
one of the things which I was really wrong. I really was pretty wrong about it. I used to think it's always a bad, it's always a bad thing to have high entropy. But when you start to work on it, especially with the finance sector, you start to notice that entropy in itself is a representation of a lot of things, and it is something which is bound to always according to thermodynamics, will always bound to just increase. But if you can map how and the rate of change of it change, and and you can map it to certain physical properties and everything, it reveals a lot about a system, whether it's the financial sector, whether it's a particle system, whatever. So entropy, I will say, was my aha moment actually. But I'll say the most impactful one in itself is how entanglement and correlation could be, interrelated. And entanglement gives you a superior, more information than your usual correlation matrices. I think these two were always something which I mean that's what I can think of at least. But yeah, right now that's all I have.
Okay, as someone who's active in advocacy, how do you avoid oversimplifying quantum ideas while still keeping newcomers engaged?
I'll say by asking them, to stay in touch. And I say that in a way that, and because I don't want to scare them away. If someone is interested in this sector, even I will end up maybe sometimes oversimplifying it. And when I say oversimplifying, maybe I also will, say that certain concepts in a way that on the theoretical level is not the best way to explain it, but might be the best way to explain to the other person. So I always say that, to stay in touch. And I always, try to at least, try to, just touch bases with them whenever I get time, obviously, but I try to do so. And by doing so, what I do is, and okay, another thing which I do is after, I meet anyone who asks, who probably, ask me for my opinion and to, explain something, I always share a video or a lecture, a theoretical one, obviously, always. So that, after I'm done, so that if he has some understanding, he should go back to the lecture. And I have noticed mostly, they come back and, they have some more actually legit questions. And yeah, and by the time, they have reached that state of mind where, they can ask legit questions, it's already done. They already, are on the right way. So that's usually how I handle it. But yes, I'll say this is also not with me, but with everyone who tries to, advocate quantum computing or, tries to work, let's say, talk about intuition, you'd end up oversimplifying things sometime. Like, you end up explaining superposition with a flip of coin. I mean, it's just a very crude representation of what it really is. But at the same time, it helps you draw, have a picture in your mind. Because I cannot explain quantum mechanics to you and expect you to have any picture in your mind, because I cannot have an picture in my mind when I talk about it. So yeah, yes, we do oversimplify things, but in my case, I usually follow it up with a theoretical lecture or something. So that helps. At least for now, that has helped.
Well, quantum mechanics is a hard thing to get your head around, right? I mean, Richard Feynman had the famous saying about, you think you understand it, you don't understand it, right? Like, and it's just so counter to the world we live in, the world we experience, kind of some of these quantum phenomena, that if you're confused by it, one, you're paying attention, and two, you're in good company. Like, if Richard Feynman was a smart guy, right? And, Einstein himself kind of was very skeptical of it because he said it sounded, the spooky action at a distance was his term.
Yeah.
It was a derisive term. Like, it wasn't like he called, he stopped short of calling it BS, right? Like, I mean, so yeah, I mean, if it is hard to get your head around, and I think that's solid advice, right? Like, don't feel bad if you don't understand it, because some of this is really hard to understand.
I agree. And exactly how you put it, man. I mean, it's the fact that you don't understand this is the fact that you're putting really your time into it, and that will always be the case. And you can say that Einstein's that whole thing led to the EPR paradox, and that led to proving itself how quantum mechanics really act. So I think that it's always the curious people, whether you are in favor or against quantum mechanics, is what really helps.
Right.
That's the case.
What do you think the quantum industry still gets wrong about timelines? And how should practitioners communicate uncertainty more honestly?
I'll say that one of the things which I think would really use some better point of view is that, you don't have to wait for the right hardware to start working on the technologies. I personally advocate for this thing called being quantum ready, and writing quantum ready software. And I'll say, just to explain what quantum ready means is it's more of a quantum inspired algorithms, but it's capable of being run on a real quantum system once it reaches a particular point of maturity. So it's like saying that, yes, I have the code which works. Right now, I use HPC systems to simulate and get results and still get minor benefits. In the future, when we have the right QPUs and quantum processing units, we can just switch over and work on that. So I think that's one of the sectors which I feel should be focused more, at least from a software point of view. Because yes, I obviously I cannot deny the fact that hardware is the backbone of this sector. Like any other sector, like artificial intelligence, AI, right? If you don't have the right GPUs and the GPU architectures, you can't even probably imagine of running half the things which we come up with. But at the same time, you still have to come up with things, right? You have to find better ways to do it on the current system, meanwhile the architecture is being built for the future system. So I think that's one of the things which I think is probably lacking in the timelines. They talk about the hardware and then they talk about the software. They always say that this is how software will look like when the hardware reaches this point. But what about the in between? I think that would probably have some work.
Interesting.
Yep. So sorry, go ahead, Frank.
No, it's just interesting.
I was going to say, so what skills outside of physics and math do you think are the most undervalued for quantum engineers today?
I'll argue and say computer science as a skill really helps in quantum computing, and why is that is I think computer science really helps you build a problem solving capability. So what I mean to say when I say computer science, I mean to say a problem solving skill is something which is really undermined, because people usually talk about, yeah, you need to know maths, you need to know your quantum stuff. But what about problem solving? Yeah, I have this information. Let's say, I am an expert, I have a PhD. I mean, as I said, we do need PhDs, yes. But I feel more than that, we need PhDs who knows how to apply their thesis in real world applications. Yeah, I mean, yes, obviously, you could have the best thesis, you can have the best results. But if you can map it to a real world problem or a problem of a sector which initially, when you thought about it, it wasn't for that sector. But later you figured it out that, okay, this also could be an application of my work here, could also be applied here. So I think problem solving and mapping problem to a solution, a very undervalued skill, very important skill for a niche technologies where I'll say, people talk about it, people say that it's a very difficult industry. I say that there's a lot of potential here. You really have the canvas, you have the algorithms, you have all the world problems of the world. If you can map it, you can get the money. I think that's also one of the ways to look at this, whole thing as well.
So if you were going to build your own quantum team from scratch, what mix of backgrounds would you prioritize and why?
I'll say I'll always get a software development guy, obviously. Because, you need someone to write the good code, good quality code. And I'll get someone who has a very good understanding of the maths and, this quantum stuff. And obviously, I'll get someone like me who can bridge the two. So, I mean, and that's kind of my philosophy back when, in one of my previous corporation where I was leading the quantum team, that was my philosophy. I always had one PhD or one, usually a bachelor's or a master's guy, and a guy, who was just an enthusiast. He was like a jack of both. He was not best at both, I'll say. I'm never good at, I never say that I'm very good at quantum physics or I'm very good at, coding. I'm somewhere in between. I can do both. And that's what, I mean, if I had my ideal team, that's how I would like to have it. Because that allows me to do is that I can give these three people one problem. I'll say that, okay, work on solving a partial differential equation on quantum computer. And we have a coder, we have a physics guy, and we have someone who can just help both communicate. That's it. That's all you need.
But you do
Especially
need
from
the
that.
communication. It's important that you have the
Yes.
people that know how to
Yes.
communicate. It's
Yes.
always important for us that,
Yes.
those
Right,
folks
right,
are
right.
vital, right?
Yes. Yes.
Hmm.
It's such an
Okay.
underrated skill for a lot of things, right?
For
Right.
sure. For sure.
Hmm.
If you can't put your point ahead in the right way, it becomes an issue.
So if you were to look ahead 5 to 10 years, what would success in quantum computing actually look like to you beyond headlines about qubit numbers?
I'll say it would be about bringing ROI, to the stakeholders, because that's something which I personally had to deal with in one of my previous ventures. That yeah, you can explain all the tech, you can explain all the theory, and you can explain all the potential advantage, right? But at the end of the day, it's about money. I mean, whether we like it or not, if someone is going to put in millions of dollars, because that's the amount of money you will need to run anything on real quantum computer. If someone's going to put that, they need an ROI, a return on investment. So I think that's one of those things which will really separate an R&D focused company from a real quantum industry tech. I think that's something which will really be the case. You can have all the qubit numbers, but if it takes you 1 million to solve a and 500K problem, then it's just going to be limited to being a research paper and nothing else. So the real edge would future would lie to solve a 2 million problem with 1 million compute. Let's say just an example.
Okay.
Yeah.
What's one
Yeah.
of the biggest misconceptions that you have heard about quantum computing?
That it can solve anything.
Okay, that's
Yeah.
fair.
That
Right.
you give it anything and it will just give you a solution faster with a higher convergence rate. That's now how it works, unfortunately. I wished it did. And if it did, yeah, then we would be going places. At least I would be going places. No, that's not the case.
What role do you think cloud access will play in shaping who actually gets to experiment meaningfully with quantum systems?
I think cloud access is the most, I'd say, it's like an underdog, but I'd say the backbone of any kind of, exposure and any kind of, I'll say, the exponential growth which the quantum has seen as an industry, because it allows you to get access to world class technologies and world class devices just from your home. So I think that's always going to be one of the most primary agents which really drives any kind of innovation in this sector, because obviously I say that in a two-tier way, right? Obviously, as a corporation, you get all these accesses and everything from your own from your own company. You can just send a process which needs to be run on their let's say quantum processor and get a result, which is a good thing, because that means that there's a data security involved in this. And as an individual who wants to get into this sector, I do not need to spend millions and thousands of dollars just to get access in 5 minutes or 10 minutes on running a real something on a real system. So I think, yeah, I mean, the cloud access is one of those things which has really led to whatever growth in exposure and the popularity of quantum computing which we have seen so far. I think it was same for AI, if I'm not wrong, right? I think it was the access to these, especially players like AWS and Azure. It was that the fact that they came into existence, and these cloud services allowed companies to just put their architecture there and scale as they go. So I think cloud in general, quantum or AI or any other technology is always the driving force. You know. Because nobody could, I mean, if you can't possibly ask a startup, with no funding of actually to just get access to these, these H100, all those kind of systems, which probably will cost them their kidneys actually. So I think it's always the cloud which drives innovation. Yes. And same is the case for quantum.
Okay. Okay. So where could people find out more about Rune, about your company, about what you're working on?
Well, about what I'm working on, probably you can follow me on LinkedIn and connect with me on LinkedIn. As I said, I'm very open on, connecting on LinkedIn. You can probably text me, and if you have any questions from this, you can just hook me up and I'll probably answer it. For Rune Technology, I'll suggest that you visit our LinkedIn page. We also have our website. I'll probably give you the link if you want that. You can just put it there with this recording. But yeah, I think LinkedIn, texting me directly would be the best way if you want to know anything about quantum computing or related stuff. Yeah, you can just probably reach out to me on LinkedIn.
That's
Excellent.
great. Well, thank you.
Thank you. This is great. Like, I love talking not just to like experts in the field, but also founders and co-founders, because clearly you went from, maybe you had to you're putting your butt on the line. That's basically what I'm saying. Like, and you're a true believer, right? And it's also an inspiration to other people, right? Like, for people who are sitting in a cubicle somewhere, or and not happy with what their current career path looks like, and the urge to pick up a book on quantum computing is far less risk than the risk that you've taken, right? So so go out there, kids. Learn something new. Is basically what I'm saying.
Yeah.
Exactly. I love it. This has been great.
Awesome.
Thank you so much. So much.
Awesome. And we'll play the outro.
Yes.
Music. I'm sorry. Go ahead. I'll let you finish.
Yeah, I was just concluding saying that it's always a pleasure to talk about quantum computing, and as I said, I like to advocate for quantum computing in itself, because with AI gaining so much traction and everything, right? I feel the next big thing might be quantum, even if it's not the case, right? You learn something, and you can always apply it to your own use case, whether it's a big thing or not. Because
Right.
I don't like one last thing just before I conclude is I don't like the fact that people get into quantum thinking that it's going to be the next big thing. Get into
Right.
it thinking that if it can help you or not. If it becomes the next big thing, good for you. If it does not, you learn something new and you learn how to apply it to your use case. And trust me, man, if you really do something, that becomes a big tool. That's it.
Yes,
That's all I'm saying.
I agree. Always learn. As Frank says, always be learning.
That's
Right?
right. Always be learning.
Always be learning.
Awesome. Now we'll play the outro music.
Quantum podcast, turn it up fast. Candace and Frank blowing my mind at last. Quantum podcast, they're breaking the mold. Science and sky beats, it's bold and it's gold. Entangled atoms, they're sharing a glance. Frank's got a joke about a quantum romance. Candace drops knowledge like a trumpet blare. The speed of their banter, nothing compares. String theory strumming, reality humming. The cosmos is bopping and we keep on drumming. Quantum podcast, turn it up fast. Candace and Frank blowing my mind at last. Quantum podcast, they're breaking the mold. Science and sky beats, it's bold and it's gold. The multiverse is skanking in time. Black holes are wailing in a horn line so fine. From Planck scales to planets, they're connecting the dots.